how disaster struck the Great Belt. A boring machine hit a water pocket. At first, water began to drip in. Then it started to pour. A special safety hatch should have contained the flood, but it had been left open. Water flooded one tunnel, crossed through the emergency tunnels, and flooded the second. It took a year to get the project back on track. The tunnel here differed from the Oresunds in another way. It went right across the channel, so heavy trains wouldn't have to use a bridge at all. This gave engineers more design options than they had at the Oresund. They were able to build a suspension bridge, and they did so in a big way. The second largest in the world, spanning nearly 2,700 meters. The towers reach up 250 meters, almost 30 meters taller than the towers on the Golden Gate Bridge in San Francisco. Unlike the Oresund, this bridge's structure depends on two main cables draped over the towers. These monster cables are almost a meter thick and around 3 kilometers long. The main cables are actually made up of over 18,000 wires, each thinner than a pencil. They're not twisted together, instead they're stretched next to each other and bundled. The finished cables weigh over 9.5 million kilograms each. The trick to making a suspension bridge is anchoring each end of the cable. For the Great Belt Bridge, the anchor blocks were enormous, little islands unto themselves. Each weighed more than 300 million kilograms. Cable-stayed bridges like the Oresund don't have anything like this. Anchor blocks are just used for suspension bridges. But the cable can't just be buried in the concrete. It would pull right out. The load has to be spread over a large area. So as the cable enters the anchor block, the wires branch out into smaller and smaller clusters. By the time the Great Belt cables reach concrete, their load is spread over 64 square meters. It's easy to see the cable's flexibility in the anchor block.
It would take a little time but it will actually start to move. Now it's moving a little, 3 or 4 millimeters.